we're going to look at some angle facts. Let's start with this one here. Angles on a straight line add up to 180 degrees. What that means is this: because this is a straight line, when you split it up, the two parts, or three or four, depending on how many parts you split it up into, have to add up to 180. So if this was 70, this bit here would be 110, because they'd have to add up to 180. Angles around a point have to add up to 360, because they form a circle which has 360 degrees. So this angle, this one, and this one would add up to 360 degrees. Corresponding angles are equal. Corresponding angles occur when you have parallel lines. So these are parallel lines. Corresponding angle forms an F shape. So if I can draw this F on, if you look at the branches of the F, if I take this branch and go below it, and take this branch which was parallel and go below it, they would have the same size angle. Or instead, if I went above, so I've got the branch and I went above, that angle there would be the same as this branch going above. You need to make sure you call it a corresponding angle, because F angle is not allowed. If you have two lines cutting each other, then what they form are vertically opposite angles, and these angles are also equal. So this angle, and if you go opposite, would be equal. And this angle, if I go opposite with this angle, they'd also be equal. Again, if we have parallel lines, then what we can form are alternate angles. Alternate angles form the letter Z. For example, using this line, and this one which is parallel, I can form the letter Z. The angle that this bit here creates and the angle that this bit here creates are equal. Again, we can't say Z angles, you have to use the correct word, which is alternate angles. Angles in a triangle add up to 180 degrees. So these three angles would add up to 180 degrees. Angles in an equilateral triangle are all 60 degrees. This makes sense because all angles in a triangle add up to 180, and if all three are the same, if you do 180 divided by 3, you get 60. Base angles in an isosceles triangle are equal. Base angles are the two sides which are equal, not the angle that they create, so not this one, but the other two are the base angles. Just be careful, the triangle could be upside down, in which case these would be the base angles. We're now going to put all those angle rules into practice. Any angles question that you get, quite often you have to fill in all the angles that they've not asked you to find in order to find the size of the angle they have asked you to find. Now let's have a look at this quite complex example and break it down. Looking at this triangle here, we can see it's an equilateral triangle because each side has a line on it, indicating the side lengths are the same. As we said earlier, this also means the angles are all the same and they're all 60 degrees. That would be 60, this would be 60, but more importantly, this one here is also 60 degrees. We can now use that information to find x. Angles around a point equal 360 degrees. If you take this point here, then what we know is x plus 40 plus 90 plus 60 should all add up to 360 degrees. Well, 60 plus 90 plus 40 is 190, which means the remaining bit must be 170. So x is 170 degrees. Let's have a look at finding y. We're going to look at this triangle. This time, this triangle is an isosceles triangle because only two of the sides are the same length. It also means two of the angles are going to be the same. It's not the angle that the two sides create, so it's not this one, but it's the other two that are going to be the same. So this and this. Because the angle given is 40 degrees, and angles in a triangle equal 180, I know the remaining two angles, if I do 180, take 40, I know the remaining two angles add up to 140 degrees. I also know they're both the same size, so if I halve the 140, I get each one must be 70 degrees. So y is 70 degrees. We can now use this angle. What we've got here are opposite angles, or vertical opposite angles. Because this is 70, if I go vertical opposite, I know this is also 70 degrees. This is also an isosceles triangle, indicated by these two lines. Again, not the angle that the two sides create, but the other two that are the same, which means this one and z are both the same. We've said earlier this is 70 degrees, which tells us z is also 70 degrees. To find w, we're going to look at angles on a straight line. We've got this straight line here, and I know angles on a straight line equal 180 degrees. Well, if z is 70, the remaining bit to make equal 180 must be 110 degrees. That tells me w is 110 degrees. Another way I could have found w is looking at this bit here. If I show it in red, I can create an f, which means I can use f angles, or the correct term is corresponding angles, because if I take the branches of the f's, this bit here is below the branch, which means this bit here below the branch must also be the same, also 110 degrees. To find a, I'm going to use parallel lines again. This line and this line are parallel, and I can split them with this line in between. It creates a z, which means I've got alternate angles. So the angle this bit here creates and this angle here are both the same, telling me a is 27 degrees. Lastly, to find angle b, I know this is a triangle, I know that's 110, that's 27, and I know all three angles add up to 180. So if I do 110 plus 27, I get 137. And if I take this away from 180 degrees, that gives me what's remaining, which is 43. So B is 43 degrees.